right, this is 4.3 part 1. So we're recording in class today, so we need to be quiet. So we're talking about absolute values in our inequalities. So the main thing to remember about absolute value is that an absolute value is a number's distance from 0. It's how far something is from 0, and you really want to keep that in your mind as you do these problems today. All right, so if we're talking about the absolute value of x, it could be one of two things. So the absolute value of x, it either equals x if x is positive, so if it's bigger than or equal to 0. So the absolute value of x can be either positive x if x is bigger than or equal to 0, or it could be negative x if x is less than 0. So for example, if I said like the absolute value of No. If I said the absolute value of x, if I said it equals 3, well, I could have either done the absolute value of 3 or I could have done the absolute value of negative 3, right? Either of those things would have ended up being 3. So there's always going to be two things that work in that absolute value symbol. Because right here, x could be 3. That works, right? Play. Or x could be the absolute value of negative 3. I was going to ask you a question. Oh, what's the only number right here that would not make it have two solutions? There'd only be one. 0, right? Because the absolute value of 0 would have to be 0, yeah? That's a good question. I'm not sure. I'll have to look that up. We'll look it up afterward. Tyler asked, can you have an absolute value of an imaginary number? And I'm not sure.
Good question.
Now if I use this video later, yours are going to be like, who's Tyler? All right, so let's do some examples. Let's do some examples here. All right, so we're going to do 3 examples here. The instructions are find each solution set. The first one is the absolute value of x equals 4. The second one is the absolute value of x equals 0. And the third one is the absolute value of x equals negative 7. Shh, just get these written down real quick. Yeah, you can. So on the first one, raise your hand if you can give me one thing that x could be. The absolute value of what equals 4? Give me one example. Elise? 4. And don't raise your hand if you don't want me to say your first name on the video, because it does go on YouTube. So like if you don't want your first name on there, don't raise your hand. Shh. Raise your hand if you know. I'm going to send you out, okay, if you keep acting like this. Raise your hand if you can tell me another thing x could be. Piper? 4? Negative 4. Good. All right, so on this one, x equals 4, or it could be negative 4. So to write your answer, we're going to write it in the set like this. Negative 4 and 4. Those are the two answers that belong in our set. No, because we're not doing a range of numbers. We're only doing 2 numbers. So we write with the little squigglies. Yeah, Charlie? Oh, you're waiting time for a second one. All right, on B, the absolute value of some number equals 0. Raise your hand if you can tell me what number could go in there. Macy? X equals 0. Is there anything else, guys? No. There's the only thing that's going to be the absolute value of it equals 0 is the absolute value of 0. And then last on C, did you still want to answer? What happens on C? I don't want to say your name because you don't want it on YouTube. Why? Why is it no real numbers? Yeah, an absolute value only gives us positives, so we can't get a negative answer. And if we think about it from the definition of absolute value, an absolute value's definition is that it's a distance from 0. Can something be negative 7 units away from something? Not on planet Earth. Not in planet Earth. No, we're not going to use imaginary. All right, so let's do another example. We're going to make it slightly more difficult. Okay, it's the same instructions. Find the solution set. And it is the absolute value of 2x plus 5 equals 13. And I'll show you guys how to solve this. I'm gonna record. Well, let me start and not when I'm not recording. All right, so on this one, basically what we're saying here is two things can happen. Whenever you have an absolute value, it's going to be two different things could happen. All right, here's one thing that could happen. Maybe 2x plus 5, maybe whatever's in there, maybe it really does equal 13. Okay, that's one thing that could happen. But now, this stuff in here, the 2x plus 5, what else could it equal, and the absolute value of it would still equal positive 13, yeah? It could equal negative 13. So there's another thing that could happen. 2x plus 5 might equal negative 13. So as soon as you see an absolute value in a problem that you're solving, you should think, I have to do two separate things. Okay, because it could be positive or it could be negative. Because a distance from 0, it could be on this side of 0 or it could be on the other side of 0. Now you just go through and solve those two equations. You solve it for positive and for negative. All right, so go ahead and solve both of those. So when you get both those solved, you should get a 4 for one and negative 9 for the other. So basically we're saying 4 or negative 9 would work in this equation. Because if we did 4 in here, we'll get 2 times 4 is 8, plus 5 is 13, and the absolute value of 13 is 13. If you do negative 9, you do 2 times negative 9 is negative 18, plus 5 is negative 13, and a negative 13 in here works. The absolute value of negative 13 is 13. So to write our set, we just write those numbers in the squigglies. So make sure when you do a set, start with your smaller number, because we're listing them. So you do negative 9, comma 4. Do you guys remember what this kind of notation is called? That's not set builder, roster notation. This is roster notation. So I'm going to write one up here for you guys to try. These are long notes, just to warn you guys. I'm writing one up here to try. Now, don't say anything yet. Just write it down. Don't say anything out loud, though. You can just think about it to yourself. But I'm going to start in just a second. I'm only going to give you time to write it down. But do remind me next time, because I should pause it on these. The absolute value of something equals negative 8. Raise your hand if you notice anything weird about that. This is a weird problem. Elise? Yeah, so if you can hear it on the video, Elise said absolute values, what it ends up equaling, it cannot be a negative. You can't take the absolute value of something and get a negative, right? So you don't have to do any work for this one. What's the answer? You guys can all tell me.
0 with a slash.
0 with a slash, no solution. So as soon as you see an absolute value equals a negative, you can just stop right there. You say, nope, it doesn't work. Yeah. Maybe I'll make a whole test of those. Alright, so I want to write down something really important here. We're going to get to some more complicated equations. So when you get more complicated, you must have the absolute value alone on one side of the equal sign. So that's really important to remember because I'm going to give you guys some more complicated ones where there's more stuff other than an absolute value. So you have to get the absolute value all alone on one side of the equal sign before you can start solving it. So let me write an example under here, and you guys can start writing the example, but I'll go through it with you. So for example, I'm going to do that thing you guys don't like with the f of x. Let's say f of x equals 2 times the absolute value of x plus 3 plus 1. So that's the equation we're going to use. F of x equals 2 times the absolute value of x plus 3, and then at the end, plus 1. And the instructions it would say are find all x for which f of x equals 15. No, I'm using the f of x because you guys are going to have to get used to this because it's going to show up a lot later in math. And you got to just get used to it.
I don't get that part.
I'll explain it. Do you have it written down, Jack? The problem? Yeah, I'll pause it while you guys write it. Alright, so to solve this, first of all, this means, okay, our function, that's what the f of x means. Our function is 2 times the absolute value of x plus 3 and then plus 1. We're going to find all values for which our function equals 15. So this just means plug in a 15 for f of x. So now let's rewrite this, but for f of x, we're going to write 15.
Oh, I get it.
Yeah, it's not too complicated. So I'm just rewriting it, but I plugged in a 15 for f of x. Now, remember what I said at the top in green up there? We need to get this absolute value all alone here before we can do the like separate into two things part. Okay, you have to get the absolute value all alone before you separate it into two. So we need to get rid of the 2 and the plus 1. Raise your hand if you think you can tell me which one to get rid of first. The 2 or the plus 1. Ella? Pick the other one. Yeah, because we want to undo adding and subtracting first always. So we're going to undo the plus 1 first. Oh, sorry. Yeah, I need to do minus 1. So we need to do minus 1 on each side. So the plus 1 and minus 1 cancel out. On this side, we still just have the 2 times the absolute value of x plus 3. Yeah, on the other side, we've got 14. So now, can I break my absolute value up into two things?
Wait, yeah, no.
Not yet. Is it alone over here? Yeah, we have to divide by that too. We need to get the absolute value all alone. Pretend the absolute value is like an x right now, and you're just trying to get x by itself. So now we need to divide by 2 to get rid of that. So now we've got the absolute value of x plus 3 is alone. On this side, we've got 7, right? Now can I do the break the absolute value to 2 thing?
I think so.
Yes, we have the absolute value all alone. So we know that this quantity in here, x plus 3, it can equal one of 2 things. You guys tell me, what's one thing it can equal? 7. If this is 7, the absolute value of 7 is 7. What's the other thing? Negative 7. So x plus 3 equals negative 7. That's what we're going to do. That's what we're doing right now, is figuring out what x can be. We can't subtract 3 right now because it's inside that absolute value. We can't take it out. To get it out of the absolute value, you have to do the breaking into 2 thing. So x could be, let's subtract 3 from each side, 4, or negative 10. And we're going to write those in the little roster notation. So negative 10 works in that equation, and 4 works. So your steps here are to get the absolute value by itself, then break it into 2 and solve. All right, let's try one. So that was about halfway. So I want you to write down g of x equals 2 times the absolute value of 5x minus 4. And we're going to find all x that make our g of x equal 10. All right, so the first thing we should have done here, raise your hand if you can tell me my first step right here. Liv? You can add, oh, I should have plugged in a 10, right? And then we'll do Liv's first step. We'll let Liv go because she's probably really sad today. About the Cardinals. It is. Oh, I didn't even notice that. One of you guys did say for chicken fillet. I think you said chicken fillet. It's like, it's hard to think of stuff like that while you're saying it, you know? All right, raise your hand if you can tell me the second thing I need to do. Shh. Carson. Divide by 2. Those go away. So we're left with 7 equals the absolute value of 5x. Can I split it into 2 now? Yes. Someone raise your hand and tell me what 2 things should I set 5x equal to? Fiore? Perfect. 5x equals 7 or 5x equals negative 7. So now on both of these, I just need to divide by 5, right? Divide by 5, divide by 5. So x is, let's just leave it 7/5. Or, if we divide by 5 on this one, x is negative 7/5. So in your roster notation, you just do negative 7/5 or, that's a bad squiggle, 7/5. I kind of forgot I was doing a squiggle as I did it. All right, so I've got another example. We got 2 more examples. Here's our next one. I know. So we're going to solve this. 2x minus 3, the absolute value of 2x minus 3 equals the absolute value of x plus 5. So write that down first. This one's going to be a little weird. The x does have to be the same. So like whatever number we plug in for x in one of them, you're going to have to plug in for x in the other one.
Oh, I see it. I get it.
It's okay. Did you write it down? Yeah. Okay. All right. So since these are the same absolute value, these have to be the same distance from 0, right? That's what absolute value means. So if the absolute value of this quantity is the same as the absolute value of this quantity, they must be the same distance from 0. I'm going to write that down because it helps me think about it. The quantities, the things I underlined in yellow, must be the same distance from 0. So let's just pretend that like one of them, like let's say the 2x minus 3, let's just pretend it equaled 7. Okay, that's 7 units from 0, right? So what could this one be? What else is 7 units from 0? There are 2 things. 7 or negative 7. So, if they're the same distance from 0, this means they must be either, they might be the same number, right? Because like 7 is the same distance from 0 as 7. So they must be the same. Or they might not be the same. What else could they be? Cameron?
Positive, negative.
Yeah, what's a word for that? Starts with the O. Opposites. So they're either the same number or opposite. Opposite numbers are like positive and negative of the same number. This is a kind of a hard thing to think about. It's kind of tough. So here's our two situations that could happen. Either 2x minus 3 equals x plus 5. Okay, so this shows if they're the same. That means they would be equal to each other. Or they might be opposites. So let's write down the equation to solve if they're opposites. If they're opposites, then 2x minus 3 is going to equal the opposite of that, which is negative x plus 5. And we want to put that in parentheses because you want to make the whole quantity negative. You don't just want to make the x negative. So either they're the same, either 2x minus 3 equals exactly x plus 5, or 2x minus 3 equals the negative of that other one. Now we have to just solve both of those. So these are kind of long problems when this happens. All right. So on this first one, we need to get all of our x's on the same side, right? So let's subtract that x over to get them on the same side. Yeah. So 2x minus x is just x, right? Yeah. So we've got x minus 3 equals 5. Yeah, and then we just add 3 to each side. So one thing that works if it's x is 8. Because, let's see, 2 times 8 is 16, minus 3 is 13. And the absolute value of 13 is 13. And then on this side, 8 plus 5 is 13. The absolute value of 13 is 13. Okay, so that made it work. Now on this equation, what do I have to do before I can even get the x's on the same side? What do I have to do with that negative? Cameron?
Add 3 to both sides.
What do I have to do with this negative first? We have to distribute that. It's like a negative 1, right? So I've got to do negative 1 times x is negative 1x, or just negative x. Yeah, and negative 1 times 5 is minus 5, negative 5. So you have to distribute that negative first when you get one like this. When you get two absolute values equal to each other, you're going to have to end up doing that. Okay, so now I want to get all my x's on the same side first. How about let's add the 1x first? I always like to do that first because sometimes you guys forget that. Let's get all our x's on the same side first. So 3x minus 3 equals negative 5. Are you sure you still want to add 5, Clay?
No.
What do you want to do? Yeah, let's add 3 to each side. So we're left with 3x equals negative 2. And then just divide by 3. So x equals negative 2/3. So if you're going to write it in roster notation, we've got negative 2/3 and 8. That should be a squiggly. And we're going to skip the last example.
Yes.
It was just to try one of those. So you honestly don't really have any time to start your homework, sorry.
Yeah.